Okay, so finally I wanted to talk about some of the utility plugins and sort of features that weren't really features but have become features. As we were developing FOCUST and concurrently using it on real data that's sort of yet to be published, and getting external users in various labs who don't have programming backgrounds to try and use the software as well, um, these things became obvious as sticking points. And so, in line with FOCUST's sort of commitment towards improved accessibility as a platform, some of these things revolve around results handling. And we've already said that in an analysis mode in FOCUST, results tables are concatenated together and they're also bound. So between images, you have results being written to the output directory of a folder. But as a first example here, let's say that I'm capturing multiple series of data from a microscope over a 12-month period. And every single time I capture that data, I want to do some analysis. So let's say that this output folder here contains my results from a previous experiment. Let's say that this was a couple of months ago and I've subsequently captured some more data. I want to save all of my results to this one output directory. But I also don't want to have to manage lots and lots of spreadsheets because perhaps I'm not as confident with programming and I don't want to have to write scripts to combine my results together in an automatic way, but I also don't want to have to handle the results because that also introduces human error. So if we have a look at this single cells CSV, we can see that it contains some data for single cells 1 and single cells 2, and then nothing else. But I want to add some more data to this spreadsheet, and I have a common output folder here. You'll also notice that the single cells 1 and 2 original images are not in this output folder. So let's say my new images, images 3 and 4, I would like to analyze them and have those results added to my existing CSV file. Well, FOCUST will do that for you automatically. If it goes to output a CSV file to a folder and the CSV file that it needs to create already exists, it will simply append the data that it needs to append. So if we go to our single cells, we select our images, which contain cells 3 and 4, and we have a look at we select our output directory to be this results folder here. What I can then do is bring in our parameter file from that experiment, so we don't have to remember all of our parameters, that they're all just brought across. Single cell mode is activated. We're not doing any additional label processing. If I just click run, you'll see that we create another parameter file in this output, and we are on our way to segmenting these images. We can see that there's primary objects for single cells 3, so we've got 1, 2, 3 now. So we're writing all these images to our output directory so that we have them as a reference if we need to cross-check segmentation or indeed create a publicly accessible data set. So we see that's finished now, and we still only have one results table. So let's open it up and have a look. And this is the same results table that maybe we created six to 9 months ago. As I scroll down, I've got cells 1, cells 2, and now I also have cells 3 and cells 4. So if you're outputting your results to a folder that already has a results table in it that has the same data, um, so by that I mean it needs to be the same arrangement of data, the headers need to be the same, and that is checked when you create and save a CSV file as well. So you get an error if you're saving the wrong data. For example, I could not output a single cell datasheet to a spheroid folder. It would just create a single cell spreadsheet because there would be no single cell spreadsheet in that folder already. But because we've just added data onto this output folder of the same type, FOCUST has just neatly appended that data into the spreadsheet for us. So we don't need to worry about having to move data around manually. That task has been taken care of for us. The next scenario is if we have created lots of independent folders. So say I've done 3 rounds of my experiment and I have all my results stored in various subfolders, lots of sort of busy, highly organized, easily traceable data organization. And I've finally finished all my image analysis. And again, let's imagine that I'm someone that can't program, and I don't have the time to learn. I simply would like to have my data joined together and proceed with my analysis. We have a utility plugin in FOCUST. And if we go to the documentation, we can see that there's an option for us to stack results. Okay, and so when we run lots of different batches and we save everything to multiple output folders. Say, for example, you want to organize your folder system and your subdirectories so that you have visibility to the different images you've taken by folders, which is fair. It becomes awful to have to manually reconcile all that data back together again. So we actually have a utility plugin in FOCUST called Stack Results, which when you point it to a subdirectory, which we are in here, oops, just delete that, which we're in here, you'll see that we've got our subfolders here. If I click Go, FOCUST will search all of these subdirectories for CSV files that it created. And by that I mean that have names that are match with something that FOCUST would produce. So primary objects, secondary objects, tertiary objects, single cells, and the like. So we have some CSVs in here. Each of these primary objects only has 3 rows to it. We have 1, 2, 3, 4 of those primary objects folders. If I click OK, my results have all been stacked for me. So inside each of these subdirectories, results have been collected and then serially bound into the same spreadsheet, saved in the root directory that we started in. Okay, so if we open up this primary results, instead of just a single set, we now have 1, 2, 3, 4 of our primary results tables that were found in our nested subdirectories have all been added into the same spreadsheet for us. So if we don't have the time or we don't have the means to script that process ourselves, FOCUST will take care of that for you as well. And the same has happened with our secondary objects there also, which we think is a neat little feature. The next thing that I would like to show you is what happens if you have segmented your data elsewhere, but you would like to use FOCUST for the purpose of its 3D analysis and the 3D relationships between objects. So you've got your own single cell data sets in 3D, and you've used perhaps a publicly available model, cell post artist and the like, to segment the nuclei or the cells in 3D. But now you'd like to use FOCUST in order to relate those objects together and do some quantification of intensity. Well, FOCUST allows you to do that also. And again, there are descriptions on that process here as well. The first thing that's really important is for FOCUST to do what we call analysis only mode. You essentially need to have images that abide by a specific naming convention. So in your input directory at the analysis mode, you need to have the original image as well as the object types that you need to define prepended to the image title. Okay, so that's how FOCUST will find the different object types. So let me give you an example of a particular situation here. So let's say I have my original image, kindly produced by Dr. McCluggage, of some speckles. And this is a multi-channel Z-stack image. We have some nuclei here, and then we have some subnuclear condensates in channel 2, so some speckle type 1, we'll say, and then some speckle type 2 in channel 3. Okay. And let's say that we've used a different software, maybe we just did it in Python or something. Um, we had someone else's script and it ran and now everything's all separate. And we have speckle 1 and speckle 2, and then we saved our segmented outputs into subdirectories. Okay, this is the ideal scenario in which you can quite easily automate your processes for renaming these files in order to conform with what FOCUST needs you to do. So if you're using an additional software and you're segmenting an object that you know will be your primary object, so for example, the nuclei, then it's actually best to keep the original image name the same and just save it in a different folder. So that's what we did here. We segmented primary object from speckle 1 and 2, and we saved the output as a TIFF to its own folder. But if we open speckle 1 here, it's going to represent the primary object of this particular folder, which in this case are those 3 nuclei that we saw. Okay, so it has the original image name, but we've nested them in some subdirectories. The reason we've done this is that we have a plugin called Rename, and the FOCUST utility rename plugin will allow you to quickly rename all your folders with the appropriate naming convention. So it's going to pre-append primary, secondary, and tertiary objects based on the option that we select. A warning with this one is it is non-discriminate, so it will rename every file in a folder that you point it to. It doesn't care what type of folder it is or file it is, sorry. So if we open the rename files, let's have a look and find some primary objects to rename first. Okay, and we'd like to append, or I guess it's pre-append really, the primary prefix. Okay, so let's do that. And all of a sudden we have primary objects underscore speckle 1. Great. Then we can do the same for secondary. So let's open up FOCUST and rename. But this time we're going to call these ones secondary. Awesome. And the same for tertiary. And obviously this is a small example, but if you had hundreds and hundreds of images that you'd use someone else's script for, as an example, this is a quick and easy way to get the naming convention sorted in order to use our analysis only mode. So that's sort of one of the requirements of using the analysis only mode, is that you need to have the original file and you need to have the appropriate naming convention so that FOCUST knows to match the original image with the correct images, object type. Okay. So now that we've renamed some things, let's move them around. So let's grab our tertiary objects here and pop them in the same folder as our original image. Let's grab our secondary objects, put them in the same folder as our original image, and our primary objects, and put them in the same folder as our original image. So we now have a file for each object type and a file that represents each original multi-channel image. Okay, remember this is a 3-channel Z-stack TIFF, or delta vision file for each. And we have the corresponding object types. But remember, we haven't done any analysis yet because we segmented these objects without using FOCUST in another environment. So what we can do now is we can go back into FOCUST's analysis mode, and we can point to a directory here that is full of our input images, so our original images and each specified object type that we would like to use. Now these are speckles, so I'm going to select speckle mode, which, if you check the documentation, primary objects are nuclei, and secondary and tertiary objects can be 2 types of speckle. Okay, so what we need to do is tick analysis only mode. This will essentially not run any segmentation protocols at all. It will simply scan the file for an original image, And for each original image, it will try and find a primary object and a secondary object, and if relevant, a tertiary object as well. Okay. Then it will run all the analysis that we otherwise stipulate, including all the standard measurements, morphological stuff, intensity, and then any additional label processing that we choose to do. So maybe in this case, I would like to stratify my primary shapes, so my nuclei, into 50% bands, so I can see which band my speckles sit in. Are they in the core or are they in the periphery? And we're going to keep the output directory the same. Because that's what we'd like to do. Great. Let's hit run. So it tells us which image we're trying to do. We get a flag saying that we're running in analysis only mode. It's trying to open some images from the directory. And you can see here that on speckle 1, it's gone ahead and opened primary object speckle 1, secondary object speckle 1, and tertiary object speckle 1. So it has loaded the original image and the 3 segmented objects that we've produced elsewhere. Okay, so we can simply just run the analysis on our pre-segmented objects. We don't have to do segmentation in FOCUST as well. We can just use FOCUST for easily generating some results that organize themselves and relate objects in 3D in ways that we would like them to. And because we have 2 speckle types here, as you'll see in the documentation, the speckle mode also calculates some overlap and allows us to look at some co-localization metrics as well. So if we have a look in perhaps these 2 to start with, we can see that we've generated those central bands, well, the core and the peripheral bands to our speckle 1 nuclei. Okay, and then we have also got the outputs that we'd expect. In the speckle mode, nuclei and speckles are related to each other, so we get an acknowledgement of how many secondary and how many tertiary speckles are in each primary object. And then we also get a record of, for each secondary speckle, what was the parent nucleus, and for each tertiary speckle, what was the parent nucleus. Of course, because we've done some banding analysis with our stratification option, we also get to see which band those speckles existed in. So if we have a look in this primary object CSV file here, we scroll all the way to the end, we can see we've got our standard layout that we're used to from the other stuff before. Let's expand all these to have a quick look. And we can see the number of secondary speckles and the number of tertiary speckles per nucleus. We have 2 different indices for colocalization or overlapping. So we have the Jacquard and the Sorensen. And then we have the number of speckles in H1 or the core, the number of secondary speckles in H2 or the periphery, and then the number of tertiary in H1 and H2 as well. So we get to look at the spatial distribution of our speckles, as well as the absolute number of up to 2 different types of speckles in this case. Similarly, if we have a quick look at just one of the speckle types, we scroll all the way across, we get a note of which parent nucleus this particular speckle was found in. Okay, so nucleus number 3 in the respective image. And then we also find out which band it was found in as well. So because we only did H1, H2, or the 50% stratification, we get a note of its ID if it was found in that band. So number 3 was found in H2, not in H1. Okay, so this was a peripherally localized secondary speckle. Okay. So we get some pretty cool insights without really having to think too much about what we need. FOCUST has taken care of that for us. So that's the analysis only mode, and it allows us to run analysis and relate objects on things that we did not segment using FOCUST, which we felt was important to support as well. Finally, that leaves us with one more kind of section that I'd like to cover, which is the final part to this picture, and that's what do you do if you would like to run FOCUST from a macro, or if you are perhaps working in a core facility and you have access to some compute resources, but you have to write scripts or use the command line in order to run ImageJ in what's called headless mode. So in headless mode, you don't have a nice user interface to use, and unfortunately, um, this user interface for FOCUST, this is all a custom-built UI or user interface, and unfortunately, that means it cannot be macro recorded and it cannot be used in an ImageJ macro. So what we have instead is what we're calling analysis light. So instead of using the full user interface, you get this parameter dialog that appears. And you'll notice there are a number of similar options relative to our fully fledged user interface. You still specify an input directory, and you can specify an output directory as well. You can give some names to the variables as we have before, and a grouping variable. And you can also then select a parameter file. So that's how we save you from having to put all of this information into a single parameter file. Because it's a parameter file and not an optimization file, you do need to have run a mock round of analysis first in order to generate a parameter file. That being said, if you are comfortable editing a raw text file, you can come in here and stipulate what analysis mode you would like to run, whether it's analysis only, and then you can add in all your segmentation parameters as you see fit. And down here we have all of the options for the variables, as well as additional processing and stratification, skeletonization, etc. All of these flags are processed as a means by which you can simply just point it to the setup for your experiment, specify some variables, and hit go. Okay. So if we do a quick test run of this, let's go back to our single cells here. Okay. So my input directory, I'm going to change to these single cell images here. My output directory, I'm actually going to leave blank. Okay. My grouping variable, I'm going to say is light test or something to that effect. And my parameter file, which remember is going to govern all of the components of my experiment, I'm going to grab from here. Some important notes on running an analysis light mode is that any parameter file that has channel names, grouping variables, directory, etc., information that you put into the analysis light dialog, so the input directory, output directory, the variable names, and the grouping input, these will take precedent over the parameter file. So if I had some variable names written in my parameter file, but I then go ahead and write some variable names here, these ones are what will appear in the final spreadsheet. Vice versa, if you leave these blank, then nothing will be added and you'll default to C1, C2, etc., which is what we'll do here as a demonstration. So if we hit go, we have an error. What is this error? Curious. Let's try that again. There we go. I don't know what happened there. That's interesting. So we pointed it to an input, we chucked in some variables, and then we pointed it to a parameter file to execute the actual analysis run. And if we go into our folder here, we can see that we've got the same output as we would have if we ran it from the full user interface. It's just relying on a configured parameter file instead of your inputs for all of the segmentation processes. So that's finished. Great. So it's exactly the same process as before. We get the same outputs. It's just running from a small parameter, what we call a parameter dialog user interface, which means that this particular version of Focus can actually be called from a macro, and it can be run in a headless environment. So when we have a look at what that looks like, you can use the template in the documentation if you'd like to call FOCUST from a macro. So for example, if you have a macro that already segments your data perfectly fine and that really works for you, but you'd like to use FOCUST to relate your objects together like we just did before, you could then have this template, which again is in the documentation here, as there are some issues with the ImageJ recorder. You can copy this and then fill in the path to your input directory, where you'd like the outputs to be saved, any naming variables if you'd like them to be there, and then point it to the parameter file that will configure your experiment. And we can see my example here. We've got the same input directory, and I'm going to probably run this just to show you, but we've got the same input directory. Let's get rid of our results from the last round there that we just tried. There we go. So we've got Analysis Lite, which is the call for FOCUST Analysis Lite plugin. We're pointing it to the single cells images folder, which is this one. We've left our output blank, which means it's going to go to the same place. And then we've left all our C1, C2, C3 empty, so we're going to just expect to see those there. Our grouping variable's been changed to macro group, just as an example of us being able to modify the group name from this script. And then we're pointing it to a parameter file. So let's hit run, and then we click OK. And we can see the parameter file for this particular experiment has been written, and now we'll start to see those objects written in. So it's exactly the same outcome. It's just we can now use FOCUST from the macro recordable. Sorry, the script bad because it is technically macro recordable, but the recorder can be a little bit dodgy. Great. So exactly the same outcome again. It's just we've now done it programmatically. So if you have an existing macro, you can now incorporate FOCUST into your workflow as well. And again, your parameter file could stipulate analysis only, find the images from here, and then spit out the results for me. And that would all happen without you needing to use the user interface for FOCUS, which again, you cannot use in a programmatic setting. Where this becomes more powerful is when you go to use ImageJ in a headless environment. So if you're on a computing cluster or something and you don't actually have the ability to use a user interface, what I recommend is that you save this macro, even if it's as it is. It's just a lot easier to open up a file and tweak some stuff if you need to. But you can save this macro. Let's go headless macro. Save this macro, and then what we can actually do is we can open up FIJI from PowerShell or command line. I go to my FIJI folder and open in terminal to sort of simulate us using some resources remotely. All we need to do to start FIJI headless and then run FOCUST remotely is all stipulated here. So the general gist is when you're in the folder of FIJI, you can add the headless flag and that you'd like to run a macro, and then you simply just have to stipulate the path to that macro. Okay, so I believe I tested this before, so there we go, I hit up and it's all there. So we've got OpenImageJ headless with the macro, and then here's the path to that macro, except I have since changed the name, haven't I? Macro. So when we hit go, we will see that parameter file pop up, and then we can start to see all these results pour in as it processes headlessly. So I'm going to go ahead and close that just to show you that these results will keep coming out even though that instance of FIJI is now closed because the one that's running the results is the headless version of FIJI. Okay, so we don't actually have an instance of FIJI open that we can interact with. It's running in the background without user input, which is pretty cool. So you can activate your macro from the command line if the resources that you're using govern that you or dictate that you must do that. So that's sort of the end of this little tutorial series on some of the things that FOCUST can do. Again, the key takeaway is that it's all about 3D analysis and relating objects together. And we've considered as many things as we can in trying to make that as flexible and as accessible as possible to as broad a spectrum of people as possible. So again, we have the same options here in our group saved from our macro that we ran from the command line. So thank you for watching this series if you've stuck all the way. Don't be afraid to reach out if you have any questions. Cheers.